Hi, welcome back. We're up to lecture 15 here in Statistics 1. And in today's lecture, we'll do t-tests and ANOVA in R. This lecture is organized into 3 segments. The first segment will be short, but it's necessary to review the example that we'll use. Again, I'm going to use that working memory training experiment because it provides us to do independent t-tests, dependent t-tests, and one-way ANOVA all on the same data set. And you have some exposure to it already. But I just want to review the paradigm and the data and how to approach the data. So that's the first segment. In the second segment, we'll do t-tests. We'll do both dependent and independent. And in the third segment, we'll do a one-way ANOVA. And in the second and third segments, we'll actually write out those R scripts. Okay, so let's look at the first segment. And as I said, we're just going to review the working memory training example. So I started with this way back in lecture 1. It's come up several times. But again, the data are a little tricky, and the way the authors analyzed the data was a little funky. So it's necessary to look this over one more time before we actually use the data in R. Okay, so remember, the idea was, can we train people, adults, have them train their short-term memory or working memory attention by doing computerized tasks every day for, say, weeks? Can we train them such that their intelligence is enhanced as a result of this training? These authors claim that we can. Other authors have claimed that they can't replicate that result. The jury is still out on this. This is a very new area of research in cognitive psychology right now. But again, think back to lecture 1. This is a randomized controlled experiment. The population is just all healthy adults. The sample should be a random representative sample of all healthy adults, right? But it wasn't. It was just college students. So that's not really random and representative, but that's true of a lot of psychology experiments. Remember, the procedure is the training group went through what's called working memory training. You'll see that on the next slide. You've seen it before. I just want to review it. And remember, this was a pre-test, post-test design, or I should say pre-training, post-training design, where subjects performed an intelligence test before training and after training. And then we could look at the difference between their score after and before to assess their gain. So again, here is the paradigm that Yaki et al. Used. This is an NBAC task, and this is sort of a special NBAC task. It's a dual NBAC. So the subject's task is to sit at a computer and view stimuli that are flashing on the computer very quickly. So in this case, every 500 milliseconds, so every half a second. And in this case, it's a dual NBAC, so they have to monitor 2 modalities. So they have to watch for squares that are popping up on the screen and remember the location of those squares, and they have to listen to letters that are being spoken to them on headphones, and they have to remember the identity of the letter. In a 2-back case, which is illustrated here, what the subject has to do is hit a button if the current stimulus matches the 1-2 back, and it has to match in both modalities. So you can see here is the example. You've seen this before, but just to be clear, this is an example of a 2-back target where they should hit the button, because that stimulus matches 2-back and the C matches 2-back. 2-back, I've done these sorts of tasks myself. I've used NBAC in my research. 2-back is pretty easy to do, so you bring people to the lab. Most healthy adults can get near perfect accuracy on 2-back. So if they did, then they would go to 3-back. And then they would practice that until they got near perfect on 3-back, and then it would go up to 4, and so on. Now remember, the results were reported in a couple different ways, and that's why I wanted to use this first segment to review. So we're going to approach the data 2 ways when we write the scripts in R. So first, we're going to look at just working memory training versus no training. Remember, they had training groups, and then they had a control group that did no training at all, nothing. And in that case, the dependent variable we're going to look at is the score on the intelligence test pre and post. So here's the graph from the paper. We've seen this graph before, but what I'm plotting on the y-axis here is what they call their performance score. That's just the number of items they got right on this intelligence test. There's pre and post, and there's the training group and the control group. So of course, before training in the pre-condition, there's no difference, right? Because there's random assignment to conditions. That makes sense. There shouldn't be any difference before training. The exciting result, the one that's grabbed a lot of attention, is this right here, showing that the subjects who were assigned to the working memory training condition, after training, they showed a larger increase in their performance score, a larger gain on intelligence than people in the control group. Okay, so that's one way of looking at it. A second way of looking at it is, if you recall, they had actually 4 separate training groups. So it wasn't just that subjects were randomly assigned to training or control. Within training, they were randomly assigned to one of 4 different conditions, and the conditions varied by the number of training sessions. So we could just use that as an independent variable, and as a dependent variable, just look at the gain score. And we'll do that because that's how they reported it in this graph that you've seen before. So on the y-axis, we have gain on the intelligence test, so that's post minus pre. And here we have these. Remember, it's important to note that these are 4 different groups of subjects. So this is a between groups design. Some subjects did 8 sessions, some did 12, some did 17, some did 19. And this was really the more impressive result. I do research on working memory, and I know the folks who did this, and I know people who are trying to replicate this work. This was the one that made us all a little more convinced that this was a real effect, because the increase is sort of like a dosage function of the number of sessions. So we can do an ANOVA on that, and we'll do that in the third segment. So in the next segment, we'll do t-tests. I want to do both dependent and independent. We'll write a script, and one thing we can do is just look at pre to post. Is there a difference? So within a group, remember, dependent t-tests are used when you have the same subjects in 2 different conditions. So we can just look within a group, was there an increase from pre to post? To illustrate independent t, I'll just use the gain score as the DV for convenience, and then we can compare just people who did training versus people who did control. And then finally, to illustrate an ANOVA, we need more than 2 conditions, right, to really illustrate the power of ANOVA. We'll use that number of training sessions manipulation. So there we have 4 groups, and again, we'll just use gain as the DV. So that's just the review of the example and how we're going to approach the data as we write these scripts to do t-tests in R in the next 2 segments.